In this chapter, we will discuss about the basics of the integrations, the core concept and area simple curves. So a integrate a to b fx dx. How can we represent this? So this is a dx and this is the length is called y. So area is written length into breadth, that is y into dx, and this line is showing the curve, that is fx. So fx equal to dx, and fx whatever equation it will be y dx. Okay, and the limit we can create from here, x equal to a to b, that will be represented, that distance will be added from a to b. So lower limit is a and upper limit is b, we can calculate. And the defining the integral in actions, so like fx equal to here 2x plus 4, and lower limit equal to x equal to 1 and x equal to 3. So step 1 is integrate from 1 to 2, and fx we can write 2x plus 4 dx. When we integrate this value, that will be x square. So x square upon 2, so 2 and 2 will be cancel out, and 4 is written 4x from 1 to 3. And when you put the value from 1 to 3, first we have to put the value of 3 here. So it's 3 square plus 4 into 3 minus 1 to the power, that will be uh, 1 to the power 2, or that is 2 to the power 1. 1 to the power 2 plus 4 into 1. So it will be 9 plus 12 minus 4 plus 1 plus 4. It will be 16. And then the absolute area rules. When a curve enter the negative plane, the standard integral else a negative numerical value, and the find the total physical area. The region must be split as the axis intersection, treating negative sector with an absolute value constant a equal to mod of a1 plus a2, that is from -1 to 1, -2 to 1 here, and then again here x equal to 1 to 2. So it will be represented like -2 to 2 or -2 to 0. So it will be x cube dx 4 minus 4, and 0 to 2 it will be x cube dx plus, that is a plus 4. So total area is a modulus of 4 plus 4, that is total 8. We will calculate. So here it's a plus 4 and this is a minus 4. Okay, so we will always take the positive value because it's the area, so it will be always positive. The complexity gap here, the rational function, suppose px and qx. So px represent x square plus 1, and x square minus 5x is that is qx. The standard rule fails. So what we do, we will do ux dot vx. Ux dot vx, we will transport into vx two function, the product of the two functions. Standard rule fails, require integration by parts. Okay, so integration by partial fraction, we can do that. It will be decomposed into minus upon x minus 2, and 10 is written x minus 3. This will be decomposed when we don't have this exact formula to simplify the fractional algebraic fractions. So we can decompose into two parts, and then we know the integration of each part, so we can easily do that. The distinct linear fraction, when denominator is x minus a and x minus b, we can represent a upon x minus a plus b upon x minus 2, and repeated linear fraction like x minus a whole square, so it is written a upon x minus a plus b, it will be bx minus a square. And irreducible quadratic, suppose b square x square plus bx plus c, then that is written ax plus b x square plus bx plus c factors. So in this form you can break it down. Partial fraction engines like x square plus 1, x square minus 5x plus tx. What we can do, improper fraction detected, so x square by x square, execute long division. If the power is greater or equal to denominator, so we have to divide. So it is 1 plus 5x minus 5, and this will be the x square minus 5x plus 5. When we are going to factorize, so it will be x minus 2 and x minus 3. We can write a upon x minus 2 plus b upon x minus 3. Isolate and solve. When we are going to solve, one is a, this one is a 1 dx, and this is 5 1 by x minus 2, this is a 10, 1 by this one. So in this way, x minus 5 log x minus 2, and this is 10 log x minus 3. That will be the answer. I hope you can understand this part. And the tool 3, integration by parts. What is the formula? So it is a u dv equal to v dot u minus integrate v dot du. It will be represented. U is a du and dv equal to integrate with respect to v. So u dot v minus integrate v dot du. In this way we can calculate. And Euler's priority sliders, what is I, if there is a multiple fraction, so what is the preference to choose the expression? So first of all we will choose Euler's. Euler's is inverse trigonometric function. This is logarithmic, A is algebraic, and T is a trigonometric function, and E is an exponential function like e to the power. So it will be its preference is the last. First of all we will take inverse, then logarithmic, then algebraic, then trigonometric, then exponential. In this way we can choose. Okay. So integration by parts cycles like assign, transform, resolve, assembles. So Euler's to define the target like u equal to x and dv equal to e to the power dx. So differentiate u equal to dv, so it is a dx. Integrate dv equal v equal to e to the power x, that is a b. When you have assemble, that plug into the blueprint u dot v minus integration v dot du. So L is x to the power x into e to the power x minus integrate e to the power x dx. So final output will be what? E to the power x is the same, so x minus 1 plus c, that will be the answer. And then this is the integrations division tree, like analyze, integrate, integrand structures, like if the proper fraction p by q, yes, factor, denominator, use partial fraction. If it is a product of two differing function type, yes, apply Euler's rules and use integration by parts. Does it have a upper and lower limits a and b? Yes. Find antiderivative, subtract fa minus fb. Use the definite integration area rules. So in this way we can do that. If you want same question on these topics, just ping me out. I will surely provide you the same questions on this topic. So if you like, please subscribe and follow my channel. Thank you so much guys. Have a great day. Enjoy.